Okay, so this section is about using the Pythagorean theorem to solve problems. And obviously, if you can identify right triangles in the problem, you'll be able to solve it using the Pythagorean theorem. And most of the problems will either have a rectangle, square, rhombus, isosceles triangle, or whatnot. So let's just take a quick review of the properties of, like, let's say a rectangle. If we connect the diagonal of the rectangle, okay, then we're left with two right-angled triangles, okay? So this one and then that one there. All right, and of course in a rectangle the opposite sides are congruent, and we have four right angles. Let's turn our attention to the square. If we connect the diagonals of a square, the sides bisect each other, and they form four congruent sides. They're all congruent to each other, and we have four right angles as well. Okay, I'm talking about these guys there. Four right angles. And let's jump to the rhombus. So same thing. If we connect the diagonals, okay, what happens? Then we have the sides bisect each other, but the opposite sides are these sides are congruent, and these sides are congruent, but they're not all congruent. Okay, just the opposite sides are congruent. And again, we have four right angles. Okay. Let's jump to the isosceles and equilateral triangles. So an isosceles triangle, that's where we have a triangle with two sides are congruent only, and as a result the base angles are congruent, these guys here. The important thing to know is that the altitude, this is called the altitude, okay, or the height. Okay, so that is the height or the altitude. Okay, when the height bisects the bottom base, this side is congruent to this side, okay? So if the whole side was 10, then this side is 5 and that side is 5. And the exact same thing for the equilateral triangle as well. Equilateral meaning all three sides are the same, are congruent. But if we have the altitude, again, we have two congruent sides. So let's go ahead and move on to some problems. Now that we have the properties of these figures identified, let's go. Okay. Alright, so a square is a diagonal of length 18 centimeters. Go ahead and find the length of the sides of the square. My advice to you is always draw a picture and make sure you identify the unknown side lengths. So in this case, we have a diagonal, and we don't know the length of the side, so we'll call it x. Let's identify what we do know. We know the length of the diagonal is 18 centimeters, and the unknown side lengths are x. Okay, do we have a right triangle? Of course we do. So we have this right angle here. All right, and now use the Pythagorean theorem. X squared plus x squared equals 18. 2x squared equals 18. This is just an exercise in algebra now. X squared equals 9, x equals plus or minus 9. Throw away, throw away that negative. We don't need no negatives in these problems. Alright, and let's jump to the final problem that I plan on covering. This is the mirror problem. It's the very last problem in your book, I believe, or one of them. So we have a mirror that's on a timber frame, so let me draw this mirror. Okay. And it's put on a timber frame, which is what the white triangles represents. Okay, I'll continue drawing and then I'll be right back. Okay, so that is the whole entire picture with all its properties. We have the mirror. It seems like the entire length of the mirror and the timber frame is 40 centimeters. So I'm talking about from there to here, that's 40. So likewise, this whole thing is going to be 40 as well. That's going to be 40. This is also 40. So let's backtrack now. We want to know the side lengths of the timber frame. So here and here, we want to know what that is. So we don't know that. Let's call it x. Now, the diagram told us that it's congruent. So we can call all of those x. Okay? And since this is a right triangle here, once we know what x is, we can use the Pythagorean theorem to find AB. So let's go ahead and find x. Now, will use the bottom as the example to help you visualize this. So what is the length of the part that I'm shading right here? Well, look at the top, it's 30, okay? And obviously this is x and this is x, and the whole thing right there is 40. So we have x plus 30 plus x equals 40. So okay, x is going to be 5, right? But if you want to see the algebra, you get 2x plus 30 equals 40, and then x equals 5 after you do all that work. So now we know what x is. We can use the Pythagorean theorem to find AB. So let's go ahead and do that real quick. So we have that small triangle. Okay, this is 5, this is 5, and this is my A, and that's my B. So Pythagorean theorem time. 5 squared plus 5 squared equals 50. Let's go ahead and take the square root of that. I don't think I have enough room, but I'll just do it up here. So square root of 50, and so AB, therefore AB, can I do it? AB equals 5 square root of 2. Okay. So, oops. So that's AB right there. And then to find the total length of the timber, how many x's do we have? 1, 2, 3, 4, 5, 6, 7, 8. So we have to, okay, we have to just multiply that by 8. Okay. But anyways, the main thing is finding AB right there. Okay, real fast, I just want to clarify. To find the length of the timber frame, all that means is you need to add up this, plus this, plus this, everything. Okay, so you found AB, and now you just need to add everything up. So we have 5 square root of 2. That's 4 5 square root of 2s, 4 of these, plus 4 30s. So that turns out to be like 148 or whatnot. So that's all. That's how we find the area, the total length of the timber frame. Okay.